Hello everyone. Today we are going to be starting uh, our mathematics course of JEE, and we are going to be starting with the maths chapter 1, that is sets. So, sets, firstly we'll write the definition, which is sets, unordered collection of well defined objects. A set is an unordered collection of well-defined objects. So there are some rules to which we can explain what is a set and what isn't. So we're going to see the rules. The rules on the basis of which we can classify uh, a collection as a set or not. The first rule is duplicate elements are not allowed. Duplicate elements are not allowed. For example, let's take a set 1, 2, 3. This is a set because there is no duplicate element. That means there is 1, there is 2, there is 3. All three of these elements are different. Whereas if we see this A, B, A, C, here we can clearly see that A is twice, that means A is a duplicate here, which is not allowed. So this is not a set and this is a set. So that was the first rule. The second rule is order of elements does not matter. That means when we talk about sets, when we talk about collection of different items, it it doesn't matter in which order we are listing the elements. So for example, A, B, C, B, C, A, C, A, B. Here we have the same set A, B with the elements A, B and C, just written in different orders. So that doesn't mean that these three are different set. No, they are the same set. Okay, so the order does not matter. You can write it as C, B, A as well as A, C, B. It doesn't matter. Okay. Now the third rule is definition of elements. The definition of elements must be well defined. Now when we say the definition of the elements must be well defined, we are saying that the elements that are in the set should be well defined elements. For example, now what does it mean when we say well defined? Well, the thing is, it should not, the elements should not change with respect to the person. For example, if we say a set, sorry, a collection of natural numbers, a collection of natural numbers, we can write this collection as 1, 2, 3, all the way to infinity. Okay, so this is a well defined set. All the elements are defined. Okay, 1 is still 1 according to me, 1 is still 1 according to someone else. Okay, so if someone says a collection of natural numbers to me and my friend, we both will write the same set, because our perspective towards natural numbers is still the same. Okay, but for example, a collection of best teachers on YouTube. So let's say we have a collection of best teachers on YouTube. According to me, we can put that collection as with the elements of T1, T2 and T3. So according to me, these three teachers are the best teachers on YouTube, but that could be based on my perspective. For example, you can have a different perspective, like let's say you have a perspective of, let's say you consider T2 a best teacher, one of the best teachers, and then T4 and then T5. So these uh, are different sets based off the same collection, but the difference is on the perspective of the person. So these two are different based on person's perspective. Therefore, this cannot be defined. The collection of best teachers on YouTube cannot be defined as not, it can be defined as not a set. Okay, we can see that T2 is common in both. So let's say one teacher is considered best in by all the students. You can name that teacher in the comments. All right, so our next rule is rule I guess fourth, which is sets are enclosed within curly braces. um, these are called curly braces, that's what I call them. You on your computer you can see these brackets are next to the letter P key. Okay, so now the fifth, let's go on to the fifth. Now the fifth rule says that the sets can be expressed in two ways. First way is the roster form. This is the simple form in which we just list the number of we list all the elements. For example, let's say A, E, I, O, U. These are this is obviously a set of vowels in the English language. So we can represent this set in two ways. The first way is a roster form in which we list down all the elements. The second way is called set builder form. Set builder form. So basically in this we write x or any variable. It doesn't matter, the variable doesn't matter. Whatever this comes as the element, like x is the element. Now x has a particular property, and that property we will define after these two dots. Okay, so x is a vowel in the English alphabet. All right, so these two sets are the same set. Okay, we are just same. Okay, we are just representing these two sets in two different forms. First is the roster form, second is the set builder form. That's it. All right, that does not mean just because these are written in two different ways doesn't mean that uh, these are two different sets. Okay, these are equal sets. Okay, next, now we come to types of sets. Okay, types of sets. The first type of set that we have is called empty set. An empty set is, by the name you can understand, empty set means a set that is empty. Okay, it has nothing in it. Okay, sorry I drew the cross. It has nothing. Okay, you can, I can't rub it, but there is nothing in it. It's an empty set. Okay, we can represent, there is a special Greek letter by which we can represent the empty set. It is phi. We draw a circle and then cut it. So this is the symbol of empty set. Okay, so a set containing no element is an empty set. A set containing no element. Okay, this is an empty set. Next, the second type of set is singleton set. A singleton set means a set containing only one element. A set containing only one element. This means that there is only one single element is present in the set. Let's say for example set A. This is having some element. Let's give it small a. Okay, so this is a singleton set here. Okay, let's give B, that is 1. Okay, this is again a singleton set. Okay, the sets containing only just one element which is not defined. You can put that one element as anything. You can even put a set as the element of another set, like for example C is equal to B. Okay, here B is the set which contains 1, but still C will be a singleton set. Why? Because it, for C, B is an element. B is not a set. Although B is a set, but according to C, it is its element. Okay, for C it is a element. Okay, next, third type is finite set. Finite set. What is a finite set? A set containing finite number of elements. A set containing finite number of elements. Okay, including sorry a set containing finite number of elements. That means, for example, let's say a set a comma b comma c. This set has the number of elements in set A is 3. Alright, we have 3 elements. So this is a finite set. Okay, the like it doesn't matter how many elements there are. There could be 100 elements, there could be thousands elements, there could be crores of elements. Okay, but as long as it is finite, you can count it. I mean, of course you can't count to 1 crore, but as long as it is a finite unit, it comes under the category of finite sets. Okay, this includes phi is, like I explained previously, it is the empty set. Okay, empty set has the number of elements in the empty set is 0. 0 is a finite value, although 0 does not have a value, but uh, we won't discuss whether 0 has a value or not. I don't know that, but phi is included in the finite set. Let's move on. Now, of course, we discussed the finite set. Now we will discuss infinite sets. Okay, as the name suggests, sets having infinite number of elements. Infinite number of elements. Okay, like for example, we in the beginning we discussed a set of natural numbers. Okay, we represent this set as n. I hope that's what we represent it with, because I think that's what it is. Yeah. Also set of let's say real numbers. Okay, we represent that by r. Set of integers we represent by I. Sorry. We represent that by z. Sorry, I thought every letter is coming, the front letter. Anyways, so how are these infinite sets? You can clearly see that the set of natural number starts from 1, but it does not end. Does it ever end? Does the set of natural number ever end? It goes up to infinity, and infinity is not a number. Okay, it means that there is no end for it. Okay, next is real numbers. Real numbers, we all know. I should have discussed integers first. Integers starts from, it does not start from anywhere. The middle point is 0, then towards the left all the positive integers, and towards the right all the positive integers, towards the left all the negative integers. All right, so from 0 towards the positive side it goes till infinity, positive infinity, and towards the negative side it goes till negative infinity. Okay, there is no start, there is no end. Okay, just like time does not have a start or an end. I think I heard that somewhere, I don't know where. uh, Similar way, real numbers means they are infinite real numbers. Okay, like even between two integers there are infinite real numbers. So imagine how many real numbers actually exist, so that would obviously be an infinity. Okay, so let's say, like for example, 0 and 1, how many real numbers exist between 0 and 1? Infinite, obviously. So similarly, 0 to infinity, how many real numbers exist? Infinite. Simple. Okay. All right, so we were discussing equal sets. So equal sets are well, two sets. Basically we need two sets to say that we have equal sets. For example, we have A and B. Now given that all the elements of A exist in B and all the elements of B exist in A, therefore A should be equal to B. Hence, A and B are equivalent sets. Okay. So the definition of equal sets, A and B are equal sets. So the definition of equal sets is sets having the same elements. Alright. So for example, if A is equal to A comma B comma C and set B is equal to B comma C comma A. Alright. Now from the previous rule we know that the order of set doesn't matter. So we see that the element A, B and C, all three exist in both the sets. Therefore A is equal to B and A and B are equal sets. Okay. The only condition for sets to be equal is that if X belongs to A, then X should also belong to B. Okay, this should be the condition. If any value of X does not satisfy this property, then A and B should not be equal. Okay. Next is unequal sets. As the name suggests, unequal sets are the sets that are not equal. Therefore, we learned what equal sets are, and the sets that are not equal are simply unequal sets. For example, if A is having elements A, B and C, and B is having elements A, M, F, right? So we can clearly see that not all the elements of A also belong in B, and not all the elements of B also belong to A. Therefore, A is not equal to B. Hence, A and B are unequal sets. Clear? Next, equivalent sets. Now please pay attention. There is a difference between equal sets and equivalent sets. Okay, both are two different types of sets. Okay, we studied that in equal sets all the elements of A should also be in B, and all the elements of B should also be in A. Okay, but in case of equivalent sets this is not necessary. Okay, equivalent sets simply means that the number of elements in A should be equal to the number of elements in B. Alright, that means let's say set A is A, B and C, and set B is 1, 2 and 3. Now we can clearly see that A and B cannot be equal because both have different elements. But we can see one thing, that both have the same number of elements. That means A has 3 elements and B has also 3 elements. Therefore, we can write that the number of elements in A is equal to the number of elements in B. This symbol, the N and then the bracket in which we write the set, okay, this is we represent this as cardinality. or the number of elements in that particular set. Okay, so the cardinality of A is 3 and the cardinality of B is also 3. Therefore they are called equivalent sets. It doesn't matter that if they're equal sets. Of course, if they're equal sets, then yes, they will be equivalent sets, but just because they are equivalent sets does not mean they are equal sets as well. Okay, so okay, next one, let's move on. So that was it. Okay, uh, we studied about what is set, then we studied the rules that define sets, all right, and then we studied the types of sets. Okay, now what you should do is practice exercise questions. For this course, JE course, we will be taking into account two books. First is NCERT and the second book is R.S. Agarwal. These two are important books according to me, and so whatever we studied today, you can practice the exercises 1.1 and 1.2 in the NCERT along with examples. And exercise 1A and 1B from R.S. Agarwal. Okay, these 4 exercises should be done by you before you watch the next video, alright, because these 4 exercises are just based on what we just studied right now. Okay, remember one thing, null sets just mean empty sets. Okay, so that's it. Like, share and subscribe.